Okay, so let's look at the various changes in the PV plane and make some simple considerations given the ideal gas law. So we looked at a process where the volume went from V1 and decreased to a value V2, and the pressure went from a value P1 to a value P2. So that increased, the volume decreased. So given this, it of course is straightforward to find the temperature. It's just given by that. And given this, of course, we also have T2 as over NK. So the temperature changes according to that relationship. If we have a process, we also looked at a process where the volume decreased from V1 to V2, but we did so at constant pressure, something like that. So the pressure is always P1. In this case, we have a temperature T1 given by that, and a temperature T2, which changes because of this, right? And so we can say that since V2 is less than V1, we have that T2 must be less than T1, right? So T2 over T1 is equal to V2 over V1. A process that's also constant in one of the quantities in the PV plane, such that we remain at volume V1, so we go upwards like that, P1 and P2. In this case, we can say that T2 over T1 is equal to P2 over P1. So it's basically clear that T does not change, right, only if the combination PV is equal to constant. So P1 V1 must be equal to P2 V2, or V1 over V2 is equal to P2 over P1. And so pressure, that means that T doesn't change if pressure increases or decreases by the same amount as the volume decreases or increases.